Good morning, Year 4. Today's lesson is an on-demand lesson, so you'll have this video of me going over the teaching points. Make sure that you rewind it if you need to hear it again, or you watch it all the way through. Watch it 2 or 3 times if you feel like you have to. So today we're going to talk about factors with regards to multiplication. I'm going to use my counters here to make an array like we did yesterday. Now you might want to use counters in your house, you might not have counters, you might want to use Lego bricks, pieces of pasta, anything that looks similar or a similar size would work here. So I've got an array here. The array is 2 down, so it's 2 times and then it's 3 across, 2 times 3, and we've got 2, 4, 6. Okay, now for today's lesson we're talking about factors. So in this multiplication here, the 2 and the 3 are factors because they are numbers that you multiply together to get the product here. The product is what you end up with. Think about it as if you're in a factory, the product is what you'll have at the end of the factory line, at the conveyor belt. So factors are what you multiply together to get a product of 6. So 2 and 3 are factors of 6. Okay. Now I could move these counters. Actually, I'm going to get 6 new counters. Right, but this time I'm going to place these counters in one straight line like this. Okay, got the same number, but this time I've got 1 and I've got 6 here. So I've got 1 times 6 equals 6. So this time I've got 1 and 6 are factors of 6. Okay, so far when we're talking about 6 as the product, I've found 2 is a factor, I've found 3 is a factor, 1 is a factor, and 6 is a factor. Okay, so there aren't actually any more factors when the product is 6. When the 2 factors go together like this, we call them a factor pair. So 2 and 3 are a factor pair of 6. Pair means 2, like a pair of socks. So they are a factor pair. Okay, right, so let's move on to the next one. So the question might be, what are the factors of 8? Okay, so I'm just going to move that and get a fresh page. So you might be in an assessment and it says write down all the factors of 8. Right, I'm going to put 8 up there just to remind us. Okay, I'm going to get 8 counters. Here, and the easiest one to go with is to line them up in one straight line here. So I've got 1 and 8. So the first multiplication I can find is 1 times 8 equals 8. Remember, we're looking for all the factors where the product is 8, so the answer has to be 8. So right, down here in my list, these are going to be my list of factors down here. So I've got 1 and I've got 8. Right, 1 and 8 are factors now. Right, I'm going to use these same counters to try and find a different way that I can find factors. Right, I wonder if I can find 3 times something. Right, so actually 3 times doesn't work because you can see the missing gap here. So it's got to be equal. So 3 times something can't give me the factor of 8. What about 4 times? Aha. So I've got 2 times 4. There we go. So 2 times 4 is equal. 2 rows of 4 will equal 8. So down in my factor list, I've got 2 and I've got 4. Any other ways? Right, what about if I put it like this here? Right, so here I've got 4 times 2. So if I write 4 times 2 here, yes, 4 times 2 gives me 8, but I can't add 4 and 2 to my factor list because they're already there. Okay, one of the special things about multiplication is it doesn't matter which way around you do it. You can do 2 times 4 equals 8 or 4 times 2 equals 8. So I've found the factors there. Let's just try 5. If I go 5, that's not going to work because I can't get an equal grouping there. Right, so it might be that I do it with a much higher number. So here I've got 24 counters. So my product is 24, and the question might be find all the factors of 24. So I'm going to line them all up. Might run out of room here actually. I'll tell you what, let's move that down a little bit. Let's pop them up here. So it's 24, what's that, 6, 7, 8, 9, 10, 11, 12, 13. Or I may even run out of room on here. That's a lot of counters, isn't it? Right, so I am going to try and squeeze them up. Can you see one there? Right, okay. So let's just zoom out a little bit more. I'm determined to get them all in. Right, and let's get another one there and there. Right, so there I've just about got 1 times 24 gives me 24. So down on my factors list here, I can write down 1 and 24. Now I know 24 is an even number, so it will definitely work if for 2 times, won't it? Because even numbers can be halved. So I'm going to make my array again. I'll move that so you can see what it's doing. So I'm making a new array and trying to find out what I had to multiply by 2. Now some of you will be quick with your maths and you'll know your 12 times tables and you'll know your 2 times tables. So we've got 2 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can say 2 times 12 equals 24. So down in my factors, I can say that a factor of 24 is also 2. And I can say it's also 12 there, because they multiply together to get 24. Right, now, does it work with 3? So if I go 3, does it work? Let's have a go and make it. Oh, it does. So it's equal. So it does work. So I've got 3 times 1, 2, 3, 4, 5, 6, 7, 8. So 3 times 8 equals 24. I can check it. 8, 16, 24, yes. So 3 goes on my factor list and 8 goes on my factor list here. Okay. Right, now let's try 4. I'm thinking that if 2's go into it, then 4's might do as well. Let's move that down. Right, let's try again. So now they're in groups of 4. I'm going to see if it's an equal grouping. There we go. My assumptions were correct. So I've got 4 times 1, 2, 3, 4, 5, 6. 4 times 6 equals 24. So 4 and 6 are factors. You can't see that. I'll move that in a moment. But I'm writing it down here. 4 and 6 are factors. Now 24's got a lot more factors than the 8 has. That sometimes happens with higher numbers. Now 5's, I could go and do my array, but 5 is 5. In the 5 times tables, do we get to 24? 5, 10, 15, 20, 25. No, so it's not going to work. I will prove it. That's a group of 5's, so let's put them into a group of 5's here. And there we go, we're missing one. So that one doesn't work. And then we go up to 6's, but I notice here we've got 6's here. So it's going to be 6 times 4 equals 24. And we've already got the 6 and the 4 as factors, haven't we? So when we get to that point where they cross over, that's the point that we can't find any more factors. So we've now found all the factors 424. Like I say, if you need to watch that again, rewind it and watch that again, okay? Now I know what some of you might be thinking. You might be thinking, right, okay, how do halves and decimals work with that? If you've got 2 times 2.5, yes, you would equal 5. That doesn't mean that the 2.5 and the 2 are factors, because a factor needs to be a whole number. So you can't use fractions or parts of numbers. They must be whole numbers. So let's have a go at making some fact families. I've got 18 here, so I'm going to try and find all the factors. Right, and this is a slightly different method to the array method as well. So I know that some of the factor pairs are always going to be 1 times the number itself. So 1 times 18, that's a factor pair there, one of them. Right, let's see if I can find any more factor pairs. So instead of going 1, 2 times. Now I know it's an even number, so 2 times something will give me that product there. Now luckily I know my 2 times table, so I know 2 times 9 would also be a factor pair there. Right, so does 18 come in the 3 times table? 3, 6, 9, 12, 18. It does. So I've got 3 times 6 would also get me 18. So I know 3 times 6 is also a factor pair there. Okay, so those are the factor pairs of 18. So I'm going to use them to make a bit of a fact family. So 3 times 6, I could have 3 times 6 equals 18. I could swap it around and have 6 times 3 equals 18. I could also use that multiplication to find out a division as well. So if I go forwards, I can go backwards and use the division as well. So I can get 18 shared between 6 people would give me 3. Or I could say 18 shared between 3 people would give me 6. I'm using the same numbers, but I'm doing the multiplication and division, and that's what we call a fact family. And it's useful to know that the division is opposite the multiplication, and if we know the multiplication, we also know the division as well. Okay, so that's called a fact family.